Hello everyone, so welcome back. So in this video, we are diving into one of the most essential tasks in remote sensing, and that is image classification. And for that, I am gonna use ArcMap. Okay, so we'll walk you through the step-by-step process of supervised classification. So if you are ready to turn raw satellite images into meaningful land use and land cover maps, so make sure you watch till the end. Okay, so at first you must be open ArcMap software or ArcGIS software. So after that we have to add the satellite images. Okay, so this is the satellite images for this video. I am using Landsat-9 satellite images. Okay, so this is basically it is the Landsat-9 Level-2 data. Okay, so if you open the folder, you can see here there are a lot of files are there. Okay, so here is a MTL file. So it is basically contain the information about the data. So when this data is taken and which time, which sensor is used. So all types of information are in there in this file. Okay, and there are some supporting files also are there. So now the question is why I am using level 2 data. Okay, why I am not using level 1 data. So there is a reason behind it. Basically, Landsat level 2 data is already processed for surface reflectance. So which means atmospheric effect like I can say that haze, aerosols and water vapor. So all that kind of errors are corrected. So this makes the data ready for accurate land cover classification, change detection and vegetation analysis. Okay, so on the other hand, level 1 data contains top of atmospheric reflectance or radiance data, so which still includes some atmospheric distortion. So if you use level 1 data, you must perform additional some pre-processing, so like atmospheric correction before the classification, so which may takes more time and effort. So that's why you can easily use the level 2 data, and it's already available in the website like USGS, Earth Explorer, Glovis. So you can choose your study area and you can download the level 2 data, so which already processed for surface reflectance. Okay, so that's why I prefer level 2 data. It saves times and gives better result for classification. Okay, so before the classification you must be know about the data. So that's why I prepared a table. So you have to look into this table. So this is Landsat-9 OLI sensor. Okay, and TRS band information are there. So basically there are total 11 bands are there, and as you know that Landsat have spatial resolution of 30 meter, but in the case of panchromatic band, that is the band number 8, and band number for band number 8 it is 15 meter, and for band 10 and 11 it is 100 meter spatial resolution. So these are basically the 10 and 11 thermal bands. So as you can see here, band 2, band 3 and band 4 and band 5. So these are basically the bands I am using in this video. Okay, so these are the blue, green, red and unified bands. So these bands are basically used for the two color composite or standard false color composite image creation. Okay, so let's go into the software. So for the purpose of that, I am here selecting the band 2, band 3 and band 4 and band 5, not band 1 because as all of you can see, it is a coastal aerosol band, and for the land use land cover mapping, there are no need to be using band 1. Okay, so for saving the time for image processed, so I am using only band 2, band 3, band 4 and band 5. You can use band 6 sometimes for your according to your need. Okay, for suppose if you are if you want to create some indices, so in that times sort of infrared band are needed, so you can use it, but for this time I am using only band, these 4 bands. Okay, so I can select from band 2 to band 5. So for this, press shift and click on band 5. So all 4 bands are selected and you can click on add. Okay, so this is the basically the satellite images. Okay, so as you can see, all of you, that it is a black and white images. So why it is appeared in black in color? Because when we see a single band, it is basically the gray. We can call satellite image a grayscale image. Okay, so when we are looking into a single band, okay, so it look like a black and white images. So to creating a color images, we have to be 3 bands. Okay, that is BGR or RGB composite. Okay, red, green, and blue. So and that way you can create color composite images. And if you look a single band, you can see that the changes of the reflectance. Okay, so you can see that the changes in the reflectance. So it is a band 4. Okay, and we know that band 4 is a red band. Okay, and in band 4, this, if you see here, it is the basically these are the vegetation, and vegetation reflectance reflect in the red here. And for band 5, okay, so this is basically the band 5. So they are higher reflectance in band 5. We know that vegetation can reflect lot of energy in the near infrared, but in case of band 4, it is appeared as a black in color, because vegetation, we know that for photosynthesis they can absorb the red and blue wavelength energy and reflect the green and near infrared. Okay, so now the bands are added. So before the classification, we have to create a composite or layer stack. So how we can so this is the another part. So how we can layer stack these bands to create a color composite or standard false color composite in ArcMap. So for that you can go to search. So how you can go to search? Click on Windows and here you can go to the search. You can search here composite. Okay, composite, and enter. So this is composite bands. So here, or you can go through our catalog. So for that, located in catalog, if you go to the catalog, you can see here in the data management tools, raster, and in the raster processing, and then composite bands. So click on the composite bands. So this window will appear. So here you can add the bands like band 2, band 3, band 4, band 5 manually, or you can just here select band 2 to band 5 by pressing shift. So all 4 bands are selected, and then left click on any of the bands and drag it to the window, and in a single click all 4 bands are added. Okay, so now it's needed a output location. So it by default creating a needed a .geo database. Okay, so you can save here, or for your you can choose a folder according to your need, where whenever you are trying to save it. So for that I want to create a new file geodatabase here. Okay, so new file geodatabase, just click on the new file geodatabase. So like that, so you can rename the file I can say I can write here stack or composite, whatever. So composite bands. Okay, so enter, and again click on the composite bands geodatabase, and here you can rename the file. So I can like give a name like composite or composite bands. Okay, so save and click on OK. So wait for a while. So it will take some times. So as all of you can see that our file is ready, that is composite band. Okay, so now it's a true color. Okay, so true color composite image automatically it was created. You can see here these are the mountains. Okay, and these are the vegetation basically. So you can see the images. So now we don't need this kind of bands for image classification, single bands, because we already created the composite bands. So I can remove the files. Okay. So as you all see that the image is ready. Okay. So now how to change band combination? Okay. So just select this composite bands layer, right click it, click on properties. Okay. You can double click and also open this window. So go to the symbology, and if you go to the symbology, you can see here red band, channel red, and we see here band 1, then green blue. So we can move into the 4, 3 and 2. So 4 is now which band? That is near infrared. Now because we choose band from band 2 to band 5, so we don't add it the band 1, that is coastal aerosol band. So now band 2 band is now band 1. Okay, just like that all these bands are changed name. So now I can choose here band 432 and click on the apply. You can see here a color composite images was a standard false color composite image was created. Okay, and we know that in standard FCC vegetation look red in color. Why it is red? Because we see near infrared band in red color. Okay, so if you want to know, so these are the band combination for two color composite and standard false color composite. So 432 and 543. 5 is near infrared, 4 is red, and 3 is green. Okay, so and these are the true color composite 432 closest to human eye perception. Okay, so our image was created, but the problem is that so this is a very vast area, and suppose your study area is smaller, so how we can subset or clip the area of interest from this image. Okay, so for that we have to add your study area shape file. So already I have add this data, that is this is the shape file. Okay, so this is the shape file. So suppose your study area may be this block. Okay, so this is your study area. Okay, so this is your study area. This is your study area, this portion. Okay, your study area. Maybe multiple blocks are maybe your study area. So for that you can choose this, select feature tools, and you can select like that. Okay, so maybe these three blocks. Okay, so maybe these three blocks are your study area. So now you want to subset this area from these images. Okay, so for that, again you go to the search. Here you can search clip. Okay, search and clip data management tool here. So this is basically for raster layers. So click on it. Input raster images. So raster images, basically this is the composite bands which I want to clip. Okay, so what is the output extents? So this is basically this layer, this shape file. Okay, click on use input features for clipping geometry. Again, maintain clipping extent. You can click here. Now you choose the location. Again, you go to the composite bands geodatabase location, and here you can write study area image. Okay, suppose study area image. You can click on save, and then click on OK, and you can see here the processing was completed. So if you go here, zoom in, you can see that our image was clipped. Okay, our area of interest or study area was clipped from the entire scene of the images. Okay, so this is the image of the study area. So you can double click on it or right click and go to the properties, and here again I change the color 432 for standard FCC. For okay, so the standard FCC image was ready. Now I want to classify this image. Okay, so basically in image classification there are two methods, supervised image classification and unsupervised image classification. So I thought already you know that which one is called supervised and which one is called unsupervised, what are the techniques, algorithm are there. Okay, so now right click on it. So for that you need a image classification tools. Okay, so maybe in your software this option you can see. So you can right click on this menu bar, and here you can select on the image classification. Okay, like that, select on image classification, and the image was, and the tools basically shown here. Okay, so you can see here automatically the composite bands or study area image, two options are showing, because if you can see here two images are here. So I can remove this. So now it is showing the study area image selected. Okay, so but sometime in your software this option maybe this option is not showing the or the image is not selected here. So why? So because there is a option which have to check on. Okay, so for that you have to click on geo processing and wait. So you can click on customize. Here you can see extension. Okay, so you can click on extension and you can check this spatial analyst. Okay, spatial analyst tools. This option may be uncheck here, so you can click on it. Okay, and then close, and you can see that this section, this tool automatically select the images. Okay, so I think all of you know that for supervised classification you have to provide some training samples to software, on which basis the your software classify the whole images. Okay, so now I am gonna create some training samples. Okay, so you can click on it. This is the training sample manager, and now you can click on there is a draw polygon, so I can select draw polygon. Okay, so after click on the draw polygon, the sign was changes. You can see the plus sign was there, so you can zoom in. So this red color are basically the vegetation. So you have to be very careful when you are selecting the training samples. Make sure you are selecting the pure pixel. Or so this is the okay. So double click on it and the polygon is closed. Again, I have select here. Okay, so like that, class 1, class 2 already created. Okay, so move on. So like that. So these are the vegetation. So in that way you can select more pixels. Okay, for vegetation for your better classification accuracy. Okay, so now for the video I am selecting these three, and now you can select all these three. Okay, all these three and click on here merge training sample. Okay, so why merged? Because all these three polygons are showing the same class, that is vegetation. So click on class 1 vegetation, right? Vegetation. Okay, so in vegetation color, so click on the color and it is green color. Okay, so this is in that way our first class was ready, first training sample was ready, that is vegetation. Okay, so now so these are the basically the agricultural land. Okay, so these are the basically agricultural land. Again, you click on here, click on like that. Okay, so like that. So these are basically the agricultural land. So again merge it right here. This is basically the agricultural fallow land. Agricultural fallow. You may choose the color this. Okay. Again, so this is the small river channel. So you go there. Make sure you have to select the pure pixel. Okay. So For that, I have select this like that. So this is like that. Okay. Again, merge it. Right, water body or river. Okay. Change the color to deep color. Okay. Okay. Now click on it. So these are basically the sands. Okay. Sand. Press shift and select all this. March. Right. Sand. Okay. Choose the color like this. Sand. Okay. So in that way you can select or land use classes, land use and cover classes according to your need. Okay. So in this way I have created some other classes like grassland, settlement, agricultural land. Okay. So after creating these training samples, okay, so you can save it. So here this is the option, you can click on here and choose the location. So wherever you want to save, choose the folder or location. So this is the zip file, you can save. Okay, so this is the training samples. Study area image, name study area image, save. You can change it like study area image, like signature or training sample, whatever you can save. Okay, and then if click on this classification, if you go to the interactive supervised classification, so there are no need to opening this. Already this image you can see here, the image easily classified. Okay, so you can see here, this is the vegetation, these are the agricultural land, water body. Okay, so this in this way this is showing, we can see here. So that this classification basically depends on the your training samples. Okay, so how much accurate your training sample, the classification is depends on that. Okay, so classification accuracy basically depends on the how much pure pixel you are taking for the training samples. Okay, so this is the interactive supervised classification method. For maximum likelihood classification, you can click here, input raster bands. So you can choose the this study area image. Okay, study area image already selected, so remove, and input signature file. So this signature file is basically uh, that one which I saved a few times ago. So you can open this. Okay, so you have to change the option file to all files. Okay, so all files, and this is the signature.shp file, you have to select, open. So if you want to save the signature file uh, of these training samples, okay, so you have to click on it. So this is the option, you can click here and you can save, suppose signature or training sample, whatever, training samples. Okay, and save. So our signature file was saved. Now you can click on classification go to the maximum likelihood classification. So this is the supervised classification algorithm. So already our image was selected. So now you have to input the signature file, and this is the .gsg file. So you have to click on it, go to here, and this is the training sample .gsg. You can click select and then click on open. So already this is open, and now we click the output location. So you can save here, or you can go to the composite band. Here you can write classification. Okay, classification, save, and then click on OK. If we can see that our image was classified, but now the problem is that it is showing that 1 4 7 like that. Okay, so you have to, so these are the basically the values. Okay, so you have to check. So one is basically our vegetation layer. So you can click here, you can choose the color green. Okay, and then click on OK. So this, in that way it was changed. Now we can click on it, write vegetation. Okay, so in that way you can change all this. Like 4 is basically the agricultural fellow, so you can write here agricultural fellow. Okay, you can write agricultural fellow land fellow. You can change the color to like this. Okay, so in that way you can change all this. Okay, to according to this. So this is the way to classify an image, basically the supervised image classification in ArcGIS software. Okay, and for unsupervised classification, you can click here classification, go to the ISO cluster. This is the unsupervised classification method. You can select, click on it, image was selected. So in unsupervised classification, all of you already knows that we have to define only the number of classes. So we can choose here, suppose number of class is 10, maybe 20, maybe 100. So according to your needs, we can select the number of classes, choose the output location as I show you for the in the case of supervised image classification. So like that you can save. Okay, and then click on OK, and your unsupervised classification was ready. Okay, so if you want unsupervised, how to classify an image using unsupervised classification methods. Okay, so if you want to see a video, you can comment on it in the comment box, so I can upload that. Okay, so thank you.